start with a historic mission to the moon and the launch of India's Chandrayaan-3 spacecraft.
India is boldly entering space exploration, making waves in global headlines. Despite humble beginnings, India is rapidly catching up with space elites, USA, Russia, and China. India just admitted they have launched something so advanced that it will change everything about space exploration. As India takes a front seat in the space race, questions arise about the project's significance and India's potential as a global space leader. What is happening? Brace yourself as we explore India's top 10 developments and super ambitious plans for space exploration. Number 1. Chandrayaan missions. We've already begun receiving the first images captured by the Chandrayaan-3 spacecraft, which recently entered lunar orbit. The Chandrayaan-3 spacecraft was launched atop an LVM-3M4 rocket on the 14th of July 2023 at 2:35 p.m. Indian Standard Time from the Satish Dhawan Space Center in Sriharikota, Andhra Pradesh, India. Since the 5th of August 2023, Chandrayaan-3 has successfully entered lunar orbit and is expected to achieve a soft landing near the lunar South Pole region on the 23rd of August 2023. If successful in doing so, this will mark India as the first nation to achieve this feat. The mission aims to build on the successes of India's earlier lunar endeavors, such as Chandrayaan-1 and Chandrayaan-2. For this launch, ISRO prepared a 3,900-kilogram spacecraft costing around $75 million for a controlled landing on the moon's surface. For comparison, the spacefaring sci-fi movie Interstellar, directed by Christopher Nolan, had a budget of around $165 million. ISRO has earned a reputation for frugality, famously completing space exploration missions on budgets comparable to those of most Hollywood films. The legacy of the mission goes back to 2008 with the Chandrayaan-1, India's first lunar probe. One of the most significant achievements of Chandrayaan-1 was the discovery of water molecules on the moon's surface. The Moon Impact Probe, MIP, carried by the orbiter detected hydroxyl and water molecules in the lunar soil. It also shared high-resolution images of the lunar surface, helping scientists map the moon's topography and composition. Chandrayaan-1 also helped in mapping the thickness and distribution of the lunar crust. Following this, the Chandrayaan-2 was launched in 2019 to explore the lunar South Pole. It successfully entered lunar orbit and conducted several maneuvers to achieve stable orbits around the moon. The Vikram lander, associated with Chandrayaan-2, was intended to land on the moon's surface near the South Pole. But this did not go as planned, and communication with the lander was lost during the descent. However, other than this, the mission was a success, and the orbiter component of Chandrayaan-2 continues to function and provides valuable data. And it was the orbiter's Chandrayaan-2 Large Area Soft X-ray Spectrometer class instrument that discovered water on the moon's south pole, putting the credit for the discovery in India's lap. Number 2. Mangalyaan Mars Orbiter Mission. Launched in 2013, the Mangalyaan Mars Orbiter mission made India the first Asian nation to reach Martian orbit and the fourth space agency in the world to do so. Mangalyaan took to the skies on November 5, 2013, from the Satish Dhawan Space Center. The mission was aimed to explore Mars and gather scientific data about the planet's surface, atmosphere, and mineralogy. After a journey of about 300 days, covering over 650 million kilometers, Mangalyaan successfully entered Mars orbit on September 24, 2014. Following NASA, the Soviet space program, and the European Space Agency, this was the fourth time in world history that this was ever done. Mangalyaan was equipped with the Mars Color Camera to capture images of the Martian surface, the Thermal Infrared Imaging Spectrometer to study surface composition, the Methane Sensor for Mars to measure methane levels, the Lyman Alpha Photometer to analyze the Martian upper atmosphere, and the Mars Exospheric Neutral Composition Analyzer to study the planet's exosphere. The mission's scientific findings were notable, to say the least. It contributed to our understanding of Martian dust storms, the behavior of water vapor in the Martian atmosphere, and the variability of methane on Mars. But on top of all of this, it was Mangalyaan's cost-effectiveness that stood out the most. As is the ISRO tradition, the mission achieved its goals with a modest budget of $73 million, and it also marked a significant milestone in India's space exploration journey. Number 3. Reusable Launch Vehicle Technology Demonstrator, or RLV-TD. SRO is working on developing a reusable spaceplane to reduce launch costs, and its answer to the question is the Reusable Launch Vehicle Technology Demonstrator, RLV-TD. This is an experimental project so far, but it is aimed at developing technologies for a future fully reusable spaceplane. The RLV-TD project primarily aims to develop and test technologies for a reusable spaceplane that can take off vertically like a rocket, reach orbit, deploy payloads, and return to Earth, landing horizontally on a runway like an airplane. And of course, it would be able to do so over and over again. This will make space access more cost-effective by enabling the reuse of major components of the launch vehicle. And considering the already frugal sensibility of ISRO, we can only imagine how much India will be able to slash down in the subsequent space launch budgets. RLV-TD project includes multiple phases of development. These include the Hypersonic Flight Experiment, or HEX, the Landing Experiment, or LEX, and the Return Flight Experiment, or REX. The HEX phase kick-started in May 2016 and involved the testing of the RLV-TD's aerodynamics and thermal protection system during its ascent and descent through the atmosphere at hypersonic speeds. Later in the same year, in August 2016, the LEX phase focused on testing the vehicle's landing gear, control systems, and thermal protection during descent and landing on a designated runway. 3 years later, in December 2019, the REX phase was initiated to demonstrate the RLV-TD's ability to re-enter the Earth's atmosphere from space, perform controlled maneuvers, and land safely on a runway. So far, the reusable launch vehicle is not available commercially, but as soon as it hits the runways, space launches will never be the same. Number 4. Polar Satellite Launch Vehicle C-37. The Polar Satellite Launch Vehicle C-37, or PSLV-C-37 as the name implies, is a satellite launch vehicle. Launched on February 15, 2017 by ISRO, the PSLV-C-37 set a world record for launching the highest number of satellites in a single mission. The primary payload of PSLV-C-37 was the Cartosat-2 series satellite, an advanced Earth observation satellite capable of capturing high-resolution images. In addition to this, PSLV-C-37 carried 104 satellites from international customers and successfully launched them into orbit. Of these, 96 were from the United States. Other satellites belonged to countries like Israel, the United Arab Emirates, the Netherlands, Switzerland, and Kazakhstan. But why would all these countries reach out to ISRO for launching their satellites? Well, simple. It's cheaper. ISO has famously been to space with a much tighter budget than most Hollywood films about going to space, and this has solidified ISRO's reputation as a cost-effective player in the commercial satellite launch market. Number 5. PSLV-C-43. Almost a year later, PSLV-C-43 was launched successfully on November 29, 2018. This time around, the satellite launch vehicle carried 31 satellites from multiple countries. The primary payload was the Hyperspectral Imaging Satellite, or HISIS, which is designed to capture high-resolution hyperspectral imagery in visible, near-infrared, and shortwave infrared bands. HISIS continues to provide valuable data for agriculture, forestry, and environmental monitoring. The 30 co-passenger satellites included one from Australia, Bright Constellation, one from Canada, CanX-7, and 28 from the United States. These satellites were launched under commercial agreements for communication, remote sensing, and scientific research. The successful launch of PSLV-C-43 further solidified ISRO's reputation in the commercial satellite launch business. ISRO can clearly deliver a diverse set of payloads into different orbits during a single mission, making the venture quite cost-effective. It also highlighted India's position as a reliable and cost-effective option for launching satellites into space. Number 6. Aditya L1 Mission. The Aditya L1 mission is a proposed project aimed at studying the Sun, particularly focusing on its outermost layer called the corona. ISRO wishes to enhance mankind's understanding of the Sun-Earth connection and address important questions related to solar phenomena and their effects on Earth's environment. Aditya L1 will be India's first dedicated mission to the Sun and is set to be positioned at the first Lagrange point, L1, which is a stable point in space between the Sun and Earth. From here, the spacecraft can enjoy a continuous view of the Sun without being blocked by the Earth. Aditya L1 will capture a wide range of data, including images of the solar corona in various wavelengths. This will provide insights into the Sun's dynamic behavior, coronal mass ejections or CMEs, and other solar phenomena. This can help us better understand space weather and can have a significant impact on communication systems, satellites, and power grids on Earth. ISRO also expects to be able to study the origin and evolution of solar wind, variations in the Sun's magnetic field, and the mechanisms driving solar eruptions. If successful in these endeavors, researchers hope to improve our ability to predict space weather events and mitigate their potential effects on technology and infrastructure. Not only this, but Aditya L1 will also contribute to broader scientific knowledge about stars, using the Sun as a model. Lastly, the mission's findings will have implications for the search for habitable exoplanets and our overall understanding of the cosmos. Number 7. NISAR Collaborative Mission. NISAR is short for the NASA-ISRO Synthetic Aperture Radar, and as the name implies, it is a collaborative effort between India's ISRO and USA's National Aeronautics and Space Administration, NASA. NISAR aims to develop an Earth observation satellite equipped with synthetic aperture radar technology to study the Earth's surface. Using radar imaging techniques, NISAR will provide information about Earth-related phenomena, including changes in land surface topography, deformation, and changes in vegetation. The mission aims to study surface deformation phenomena on Earth, such as glacial and ice sheet dynamics, ecosystem structure and dynamics, and natural hazards. NISAR will carry a state-of-the-art synthetic aperture radar, or SAR. SR technology enables high-resolution imaging of the Earth's surface via microwave pulses and measuring the return signals reflected from the surface. NISAR's radar technology will allow it to image the Earth's surface day and night, regardless of weather conditions. The satellite will also generate high-resolution 2D and 3D images, as well as interferometric measurements, which reveal changes in the Earth's surface over time. The collaborative effort behind NISAR highlights both NASA's and ISRO's ambitions in advancing Earth observation and scientific research. NISAR is expected to provide valuable scientific data, supporting efforts to better understand and manage Earth's dynamic processes and environmental changes. And of course, it brings ISRO to the forefront of spacefaring organizations in line with NASA. Number 8. Space Capsule Recovery Experiment. The Space Capsule Recovery Experiment, or SRE-1, was conducted in 2007 by ISRO to develop and demonstrate space payload recovery technologies. While SRE is often overshadowed by ISRO's more ambitious space missions like Mangalyaan and Chandrayaan, it is a significant feat nonetheless. The idea was simple in theory, but complex in execution. But committed to stretching the boundaries of the possible, ISRO launched the SRE-1 on January 10, 2007, from Sriharikota, and then observed its re-entry into Earth's atmosphere after recovering its payload. SRE's main goals were to develop re-entry technology, test recovery systems, and gather data. ISRO went all out, trying to demonstrate the spacecraft's ability to withstand re-entry heat and pressure, test landing aids like parachutes, and collect data for refining future space missions. The satellite orbited for 12 days, collected its target space capsule, and then headed back home. Following its re-entry into the Earth's atmosphere, SRE-1 deployed parachutes or landing aids to slow its descent and ensure a controlled landing. It then landed with a splash at the Bay of Bengal on January 22, 2007. Number 9. Space Situational Awareness, or SSA. ISRO has amped up the space exploration game by trying to make orbits safe again. The Space Situational Awareness, or SSA, aims to monitor and analyze activities in outer space and focuses on tracking and understanding space objects like satellites, debris, and other potential threats. This will ensure the safety of space assets worldwide. SSA's objectives encompass object tracking, space debris mitigation, collision avoidance, threat detection, and space weather monitoring. So, how does it work? SSA continuously tracks space object trajectories to prevent collisions and enable safe space navigation. SSA offers timely alerts and collision avoidance maneuvers, safeguarding operational satellites. We're talking about millions of dollars saved. Of course, ISRO also plans on contributing to India's national security ambitions with SSA by detecting potential threats in space. SSA also monitors space weather phenomena that can impact satellite operations and communication systems. ISRO has a vast network of sensors and computational models to go with SSA, allowing it to keep a watchful eye on space objects and predict their behavior. SSA promotes sustainable space use and contributes to global efforts in preserving Earth's orbital environment and supporting future space exploration. And of course, sharing this information globally will also support coordinated space traffic management. Number 10. India's very own private aerospace startups. For a nation like India, which was struggling against an existential economic crisis only 3 decades ago, it is nothing short of a miracle to see aerospace startups sprouting up in what is the world's 5th biggest economy today. And these startups have ambitious space missions of their own. Hyderabad's Sky Route Aerospace launched its PRORAM mission to demonstrate the capability of their solid-fueled rocket engine named Kalam 5. This engine can power the upper stage of small satellite launch vehicles. PRORAM's success, marked by its ascent to an altitude of about 89.5 kilometers in 155 seconds, highlighted the ability of in-house developed propulsion technology. Skyroot Aerospace is among the new wave of private space companies in India that are working towards making space exploration more affordable and accessible. Their rocket engine, Kalam 5, is named in honor of Dr. APJ Abdul Kalam, the former president of India and a renowned space scientist. Another notable mention is Chennai's Agnikul Cosmos, which mostly focuses on developing small satellite launch vehicles. They earned acclaim for using 3D printing technology to make satellites in their 3D printed rocket engine test. Using 3D printing allows Agnikul Cosmos to rapidly prototype and manufacture rocket components, reducing costs and lead times. This innovative approach not only accelerates production, but also enables Agnikul to create intricate and optimized designs that were previously challenging with traditional manufacturing methods. This advantage extends to their satellite launch vehicles as well, as Agnikul utilizes 3D printing for crucial elements like engine parts and payload fairings. By leveraging this advanced technique, Agnikul Cosmos can better tailor their rockets to meet specific mission requirements and adapt to evolving space industry demands. This places India's emerging private space sector on a trajectory of technological prowess and global competitiveness. Based on where things are headed, India's state-owned space agency, ISRO, and private aerospace startups are going places. For now, let's keep our fingers closed for Chandrayaan 3's successful soft landing on the moon's south pole. Thanks for watching. Don't miss this video you see on your screen right now. You're sure to be amazed. It's unbelievable.